Hello everyone. In this video I quickly wanted to take a look at the second quarter project with a little model here. Obviously this is a simplified version. I only have a few rooms in this blueprint, but more importantly we want to go over some of the concepts here, such as labeling, area, and also evaluating. So within my drawing, let's take a closer look here. I think one thing that's a little difficult to explain, and that I hope that we're all aware of, is this idea that we're basically making up these dimensions. So for example, this 5x plus 4 is just more or less made up. The 5 doesn't mean like 5 feet, 4 doesn't really correspond to anything. We're kind of just creating these binomials. But that doesn't mean that we make up every single expression within the house. And I'll give a few examples throughout this video. I think it's best to kind of start labeling some of the smaller pieces. So for example, let's take a look right here. I just happen to call this x plus 1, and I put little brackets just to say like, hey, I'm talking about this piece right here. If I just put x plus 1, I might get confused with like exactly what it's referring to. So if you notice, if I kind of start here and work my way up, I have 3x plus 2 is referring to this piece, x plus 1 is referring to this, and then this isn't a room or anything, but I did label this as 2x. Now when we look to the right, this entire, let's call it like the width of the living room, is 6x plus 3. Now 6x plus 3 isn't made up, it's the sum of all those previous pieces on the left. So there's like a correspondence there, and this happens a few times throughout. Another example we can see is right here. I have x and x plus 6, so when I'm labeling like a length above it, notice that this is 2x plus 6. Again, that corresponds to the sum of the pieces below it. So it's almost like a puzzle in a way. That's why I said it is better to start with some of the smaller sections and then just be aware of, hey, I might have had 3 sections that were all this, and then this bigger area corresponds to the sum of all 3. Now, another thing I want to mention, if we put a room inside of a room, I guess this would be like a good example of a closet, let's say. Just be, not that, I'm not saying that you can't do this, but it might make things a little confusing. For example, let's say, I'm going to add on to my drawing here. I know this isn't straight. Let's say we had a closet like that. Now, again, this is fine if you'd like to do this. I would recommend doing it the way that I had it set up, with every kind of rectangle in its own separate, nothing overlaps, let's call it. If you do an overlapping rectangle, the only room for confusion or room for error there is your total area. We want to make sure that we're not like double counting. So if you put that closet in like the corner of your living room, when you're finding area, which we'll talk about in a moment, when you're finding area, you don't want to double count. In other words, count the area of the entire living room and then also add on the area of the closet there. You'd be basically double counting that little section. So just be aware of that. I would kind of just basically lean away from having something inside of another room. It might not be realistic. You can kind of keep it simplified like this. Obviously, you guys have like 3 bedrooms and a few more rooms. I just wanted to have a quick example to explain to you guys. Now let's focus on area. Area, obviously, I'm not showing my work here, which you guys would want to do, but this is just basically binomial multiplication, box method. I'm finding the area of each individual room. And then one of the sections says find the sum of all the individual rooms. So this is combining like terms right here. Get the laser pointer. You end up getting this trinomial. Now there's another section that talks about like the outside dimensions of the house. Just like we talked about kind of like segment addition here, like adding up the pieces to get the whole. Where did I get 7x plus 10 and 7x plus 6? It's the entire width of the house and the entire length of the house, just like we did for some of the individual smaller rooms with the bigger room. And what you should notice, this should happen if you did it correctly, is obviously the sum of the parts should equal the whole. Treating the outside house as like one big rectangle should be the same as adding up all the smaller rectangles inside. If you don't get them to match, again, your mistake might just be like double counting. You might have like some, when I've done this project in the past, people will do something like this. They'll have like, and that gets confusing with how you treat that. So I would, again, treat everything as a separate rectangle. I think that's going to be our best bet in terms of you successfully completing this project. And it should make things easier for you. Now there's a few questions that refer to perimeter. Now obviously you would just be adding up your expressions for that, but same idea. And now the last piece I wanted to talk about is evaluating. So for this, you're going to choose something. So for argument's sake, and I'm not even going to do this here, but just to explain it, you can choose something like x equals 3, and you're going to walk through the same procedure. So you're going to find the area of individual rooms. So for example, let's take a look at the closet. Maybe we'll calculate one thing here. If x equals 3, the closet would be 3, let's say feet, 3 feet by 11 feet. 3 times 3 plus 2 is 11. So 3 by 11, that would be 33 square feet. And then you would add up all the individual rooms, calculate the entire width of the house, the entire length. And now we're just doing this basically the same as part 2, but we actually have numbers to kind of support it. And obviously if it checked out in part 2, it should still check out here in part 3. All right, so hopefully I wanted to keep this on the shorter side, but hopefully this cleared up some confusion you have. Again, I'm suggesting to kind of treat every rectangle as separate. Don't overlap. It could just make things confusing. You are making up most of the numbers here. You can give some correspondence. So like, maybe if something's a bigger section, you could have like a bigger coefficient. But again, those numbers don't really mean anything. Like 6x plus 3, it doesn't, actually mean anything. But maybe it makes more sense that this is 6x plus 3 and something like this is a little smaller. So yeah, you could do something like that. But more or less, we're making it up. But look out for segment addition, parts where you can kind of add pieces together to get a bigger piece. All right, guys. Hopefully you found this video very helpful. And good luck completing your second quarter project. Have a great day.